My name's Hugo Duncan. I'm going to be talking to you about Ritz, which is IDE tooling for Clojure. I work with Palette most of the time and spend a lot of time doing debugging. So a large part of what I'm going to be talking about is debugging. My Twitter handle there is Hugo Duncan. So a bit of history to start off with. Debuggers in Clojure got really started with George Jihad. He came up with this, the realization that you could use macros to access the current variables within a frame in your code, and then evaluate arbitrary expressions using that information. So that led to the introduction of the ampersand env argument in macros. Then I ended up putting that debug REPL stuff into Swank Clojure, which was the project that Phil Hagelberg maintained for a long time. And then sometime after that, George decided to make something more powerful. So based on the JVM facilities for debugging, he started to put together a REPL toolkit called CDT that allowed you to break lines and inspect the stack, etc. And about the same time, I started Ritz with the aim of putting the Slime debugger, making the Slime debugger work in Clojure. So since then, things have changed a little bit. We now have nREPL. nREPL is Chaz's inspiration for a project to allow you to use a Clojure JVM across the remote connection. It's now tools.nREPL, the official in the official Clojure repositories. And nREPL itself is made up of a couple of things. There's a transport, so it allows you, it opens a socket for you to communicate with your Clojure JVM on, and it provides a protocol to talk to it, so beEncode. I think beEncode was picked so that it wasn't limited to just Lisp clients. So it would be easy to build clients for a Clojure IDE outside of without using Lisp. Also in nREPL is the concept of a middleware. So nREPL communicates based on messages. So it takes messages from the clients and sends it to the Clojure JVM. And each message is passed through a stack of middleware. So you can think of this a bit like Ring middleware in your web stack. So when you start the nREPL server, you specify a list of middleware, and it puts those into the path of each messages, and each middleware gets a chance to inspect the messages that get sent. Finally, it provides a session management, and by that I mean it provides a consistent environment for your dynamic vars. So because it's message-based, each time you send a message, if you update a var in one message, you'd expect to see the same values next time you evaluate a message. So that's what the session management really does. So nREPL.el then is a client for nREPL, a separate project. Don't go hassling Chaz with stuff that doesn't work in nREPL.el. nREPL.el is a project led by Tim King. It's an Emacs client, and it's essentially a replacement for Slime, but written from the ground up specifically for Clojure. As I said, it has this middleware concept, and it communicates via messages. So this is just an example of a message and a middleware. So on the client side, we have a map that specifies an op for loading a file. That message is sent to the server, where it's passed through the middleware stack, and the load file middleware says, I recognize that op. I'm going to handle it. And it loads the file you've requested, sends a status message back to the client, and the client can display whatever to say that the file has been loaded. The interesting thing about this is that it has support for not just Clojure, but Clojure scripts. So you can iron out some of the differences between the backends in your client. And your client doesn't have to worry about the differences between Clojure script, for example. Middleware also lets you have alternative implementations for things. So if you don't like the completion that comes by default in nREPL, in nREPL.el, you can switch your own one in. So it gives you some customizability. So in nREPL.el, there's an nREPL events buffer that you can actually go and see these messages being sent backwards and forwards, which is great for debugging nREPL.el, but I'm not sure if it's useful for many other things. But if you're interested in how it works, you can see the details. So Ritz, as I said, Ritz started off as a fork of Swank Clojure, but it's now been refactored several times. It's a very different code base, much more modular, split up into different projects. Although the original focus was just to provide debugging for Slime, it now includes all the implementation essentially of Swank Clojure. So all the features that were in Swank Clojure can be provided through Ritz. And it's been refactored to support nREPL. So there's a core RitzUtils library. And built on top of that, there's a debugger library without any user interface involved there. And then on top of that, you have the user interface libraries, one for Swank, one for nREPL, and there's an nREPL middleware library, which is usable outside of the Ritz world, usable with the standard nREPL servers. So the RitzUtils library provides all the facilities you'd want for inside a REPL. So evaluation, completion, Java doc, namespace dependency graphs, it's all there as a library. It's very low dependency. It just has the one dependency, which is important because this code is going to be running inside your user process. So you don't want to have conflicts between dependencies of your own code and REPL code. The only dependency in there is Dynapath, which is used for dynamic class path manipulation. So you could use this library essentially to implement a REPL in any environment that you like. I know there's at least one person trying to writing a web-based REPL that is using this. So on top of that library, then we have nREPL middleware. So these are middlewares that you can use in any nREPL server. Javadoc, apropos. There's a couple of completion ones there. There's the simple completion, which is just like tag on things at the end, and then there's fuzzy completion, which will match things like. I think of a good example. If you just type it, anyone suggest a two-component function name? Okay, read string. So r-s, you type r-s, hit complete, and it would complete to read string. So it's fuzzy completion. So those are usable within Ritz and within the standard nREPL server. There's a couple more components within the Ritz framework, Ritz umbrella. There's nREPL codec, which allows you to have a middleware that will look up the history of a function. So you select a function in your client, hit a key, and it will bring up the history of that function by looking it up in codec. It doesn't actually load the codec database. That's a separate problem. And there's an nREPL Hornet queue, which runs nREPL over a message queue. So Hornet queue is a nice Java-based message queue that you can actually run embedded. So if you have a situation where you want a REPL but you can't use sockets, then Hornet can use an alternative there. Which brings us to the debugger. So the Ritz debugger is built on top of middleware, like all the other functionality. And it uses the JVM facilities for debugging, which is the JPDA, it's known as the JPDA libraries. And the way that this works is you need two processes. So there's on the right there's the user process, which runs, and in the middle we have the debugger process, which controls the user process. So it talks to the user process using a protocol that comes with the JPDA toolkit, which is JDWI, I think, if I've got it right, or JDI. And it uses the JDI library, or the JDI classes provided by the JVM platform to do that. And then your client here in REPL.el talks to the debugger process rather than the user process. And any operation that is sent by the client to the debugger that it doesn't recognize, it just passes on to the user process. The user process handles it as normal and then returns it back to the debugger process, which forwards it back to the client. But the debugger process recognizes all the debug functionality, which I'm going to be covering in a minute. So both the user process and the debugger process both run nREPL servers. The nREPL server in the user process isn't actually listening on a port. It's using the JPDA facilities, whereas the nREPL server in the debugger process is listening on a port. So it's just like it appears like any other nREPL server. Because it's implemented in middleware, you can use this with any client you like, essentially, that provides that knows about the middleware. So you could use this to implement a debugger in a browser. So this is just another example of how the debugger middleware works. So there's when you type Alt-X break on exception to turn on breaking on exception, it sends a message to the debugger process. There isn't a reply at that point. It's doing what would be equivalent to a long polling in HTTP. It's just giving it a message ID it can reply on. So in the second message, we're going to eval some code, which is going to throw an exception. And at that point, it replies to the first message with details of the exception, which get then displayed in the client. The client can then select a frame. And in this case, we're going to look at the source code for a particular frame. So it asks for the source code location for that frame, goes and looks it up, takes replies with the file and the line number, and the user and the client can then display that. Again, there's another example of the frame evaluation. So we can evaluate an expression within the context of a particular frame. And that happens by messages as well. And finally, the final component then is nREPL, I can't even spell, nREPL Ritz and Slime Ritz, which are the Emacs packages which provide extensions to the base Slime functionality and the base nREPL functionality. So, for nREPL, this provides a version of the Slime debugger, but for nREPL. So I'm going to go very quickly through the install process because you can look it up really later. The first thing is all the packages are available in Marmalade. I think that was mentioned in the talk before this one. You can set up Marmalade and you have to do a package initialize, and that gets all the Emacs packages that to be available. And you just alt-x package install nRepl and nRepl Ritz, which is the extensions to nRepl. To run the two nRepl servers, there's a line plugin called line Ritz. And you add that, to make that globally available, you add that to your user profile in Leiningen. And finally, to run a REPL, nRepl.el provides nRepl jackin, nRepl Ritz provides nRepl Ritz jackin. So to use these functionalities, you navigate to a buffer, a Clojure buffer within your project, and then enter these commands, and it will start a session, an nRepl server, in the context of that project, and connect to it. And finally, to actually use middleware, the way you select which middleware you want to use is, again, using Leiningen. You can do that in your global profiles, or you can do it in project-specific profiles. Okay, now to the probably more interesting bit, a little demo. So I've got a namespace here. I'm going to start text nRepl Ritz jackin. Okay, and now it's going to start a REPL server within the context of this project. And at this point, it's actually starting up 2 JVM processes, so it takes a little longer than the standard nRepl startup. And I'm going to begin by showing a little example of how exceptions are handled in nRepl EL, and how we can switch on the exception handling. So there's my prompt. So in standard nRepl, by default, you just get an exception message, which is kind of nice if you don't want to see the stack traces. Sometimes it's useful to do that though. So that's all customizable within nRepl.el using the standard Emacs customization facilities. But here I'll just set it dynamically. And nRepl shows you a stack trace. If you have the Clojure exceptions library loaded, it will actually give you a nicer stack trace than that. So now I'm going to turn on the exception handling that's built into the debugger. And there are some reasons why this isn't on by default, which I'll go into in a while. Basically, we turn it on, and this time we get a somewhat bigger stack trace. So again, you see at the top you see the exception message and the exception type, and below we see the customary stack trace, and then we have these restarts. And restarts the idea of restarts comes from Common Lisp, the condition system in Common Lisp. And in that system, basically, you can write code that controls what happens when an exception or a condition is raised. And that code then runs without the stack being unwound in the context of when an exception is raised. And we can do something similar using the Java debug toolkit, except that we just provide some predetermined restarts. So you can't actually add to this list dynamically, but the same mechanism works quite well. So when we get an exception, we can choose to do several things with it. If we continue, it's going to pass that exception on to the program. And you can see it's been caught, and now it's being rethrown again. So you can do that a couple of times. We can abort, which then says, okay, don't catch any more exceptions, just go back to the top level. So I'm back at my prompt. And then we can choose which exceptions to see. And this is where one of the issues we have the Java Toolkit provides facilities for catching caught and uncaught exceptions, which you'd think would be very useful to expose. But unfortunately, it doesn't really help us in the Clojure world, because every try finally block creates a catch context, essentially. So if you have any try finally block in your code, all your exceptions are effectively caught. And it's a pretty common idiom within Clojure to have this. So a lot of the macros expand to forms that have try finally in them. So it's meaningless to filter on caught and uncaught, so we have to provide some other facilities to be able to do that. And that's what these other restarts are about. So we can choose, if we choose ignore, we'll ignore, we won't stop on any exception that has the same type as this exception. So if I ignore this, we're going to get back to the REPL, and if I pull up the expression again, it didn't stop. So of course, it'd be nice to be able to manage this. I've forgotten all my shortcuts. nREPL, caps lock on as well. nREPL Ritz. Exception filters. So there's a buffer built in that shows you all the exception filters. So this is the one I just created. This is still a bit rough and needs to look a little nicer in the UI. But this is the exception I just created. You can see there's a whole load of default exception filters, because by default it catches every single exception. So all the exceptions within the Clojure implementation, and the default filters try and filter out all the common ones that come up from within the implementation. So I can control the the filters from this buffer using the bindings that are here. So I'm just going to disable this exception filter with D. And now if I go back to the REPL, it once again breaks on that exception. So we can filter on exception type. We can filter on message, which is an exact match by default. We can filter on catch location, and we can throw on throw. We can filter on throw location. So using these filters, you can control which exceptions you break for in the debugger. And in the exception filter buffer, in this one, if you hit S, it will save your exception filters. So next time you start up the project, it will have all these exception filters already loaded, and you don't have to set them again. So that's how you control the exception filters. The Stacktrace is a little richer than the standard one. Each frame is openable, so if you just hit enter on a frame, you get to see the local variables within that frame. It's not just the first frame, it's every frame, Clojure or Java. So, and within this frame, you can evaluate expressions. So if I hit E, I can enter expression times 2x, and it's going to give me an answer in at the bottom. If you have a more complex expression, see if I can find a more complex expression. I think we've got one somewhere. Well, we'll do the form. If you hit D and enter an expression, it will print the result in a separate buffer, which is useful if you've got a long expression, if you want to copy and paste things. And you can pull up the source for a frame with V. So excuse the white space highlighting. So that's pulled up the divide source. You can see we're actually here. So that's pulled it up from the Java. Let's find a Clojure one. Clojure eval. So it's within the Clojure implementation. Screen resolution sucks for displays, for presentations. Okay, so yeah.
I'm curious, all this interaction you're doing, is this all happening inside Emacs, or is it going out to the middleware to get this information back?
It's going to the middleware each time.
So if you had this, some other client, you can have the same facilities.
Exactly.
Great.
Yeah. So when I hit enter on this frame, it's actually going and asking, sending a message to the back end, and it's saying, give me all the locals for this frame, and then it's getting the reply and putting it back on the screen. Yeah, feel free to interrupt if you have questions or you want to see anything in specific. Please put your hand up. Okay, so that's the Stacktrace. So it's going to continue. Abort. Now I'm going to go back to my example code. I'm going to compile this. And you can see here it's actually pulled up in compiling, it's pulled up a class not found exception, which is pretty normal because it's trying to find stuff that hasn't been compiled yet. So I should really add this to the standard filters that come up, but class not found is a pretty common exception, and you probably would like to see it in general. So you can just ignore this, it will carry on compiling. So now I've got a little function here, and I'm going to set a breakpoint on this. So with Control-C, Control-X, Control-B, I get a little breakpoint, and it's shown as a little arrow in the fringe. There's also a browser, if I can remember I can't remember the shortcut for it. Or Ritz breakpoints. So there's a little a buffer that shows you all the breakpoints, and if you hit enter on a breakpoint, it will jump to that breakpoint, and you can kill breakpoints from that buffer, etc. So now when I run this expression, I'm going to call F1, and it's broken at that breakpoint, and we can see we have our local variable A, which was A1. And again, we control the stepping, or control the breakpoint through the restarts. So in this case, we've got continue, which just continues on from the restart. Got continue clear, which will continue and remove the breakpoint. We have step, which will step into the next instruction, actually. It should be the next instruction rather than the next line. Step next, steps to the next line. Step out, steps out of the function.
Can you change one of the locals and continue?
Not at the moment, no.
That is exposed from the Java you gathered, so it could be added?
Yeah, it could. I don't know how useful, how many people would use that sort of thing.
I don't
Yeah? Okay. Sounds like there's demand for it.
If you reevaluate the function that the breakpoint is on, does the breakpoint go away? That was a limitation, I think, a while back.
That was a limitation. It should now be fixed. I'll show you in a second. Okay, so we have stepping. I'll just step next. And by default, it will show you the code location. Actually, the next line was an exception, so this is the exception that it threw. So if I recompile this code, fingers crossed, he says, oh, demonstration effect, it didn't work. But it's supposed to work. Okay, so I have a more complex example here, which includes it seems to have killed my session. Okay, there's another feature which is Alt-X, nRepl Ritz threads, which will give you a display of all the threads that are running. And we can actually see that one here is suspended for some reason. And I'm just going to resume that with nRepl Ritz resume all. Okay, and I got my divide by zero error back. So hopefully I can now show you the more complex example. No, it's still not liking it. Okay, nRepl Ritz has also nRepl connections. Control-C, Alt-L. List your nRepl connections. So I'm just going to kill this with Control-K and go back to my example and restart an nRepl Ritz session. So one of the issues with Clojure and debuggers is that there's locals clearing. So often when you inspect a Stacktrace, variables show as nil even when they're not, because and that's done so that you don't hold on to references to lazy sequences, so you don't end up with lazy sequences fully realized because of the debugger. So it's nRepl Ritz break on exception. The breakpoints at the moment depend on break on exception being set, so it's a limitation that's going to be removed. Control-C, okay. I'm just going to compile that. So in this case, we got the local variable, and the locals clearing has actually improved steadily with different new versions of Clojure. So less and less is nil by default when you show it. See if I can find one that's going to give me nil. Anyway, so if you in the Slime interface, there's a prefix for the compile commands that will actually disable locals clearing. I haven't got around to porting that to nRepl yet, so you have to set it manually with alter var root compiler options, and you get sock, disable locals clearing, true, and you have to recompile, and it will. It then shows you all the local variables reliably. So I think that's pretty much. Yes.
You mentioned try finally messing up the filtering.
Yes.
Is that true for Java as well? Finally.
Yes.
Okay, so it's something we can do differently.
No, I've tried it in Eclipse and IntelliJ, and just with the Java try finally block, it has exactly the same behavior.
Finally itself is that Clojure's bytecode.
No, it's not the bytecode that's being generated. I don't see how you can avoid it without. Possibly if you put in special bytecode for that situation, so you allow the debugger to recognize it, but that sounds like a bit of a hacked.
Find out something that we can do to help it.
Yeah, it's pretty frustrating. So if we could come up with a solution, that would be ideal. Yep, sure.
Yeah, what is let's do when you're displaying locals that are large or infinite lists? Locate them, or?
It should. Well, we can try. We'll see. It should just display some ... dots. I haven't tried it recently, so we'll see if we break it. Oops. I can't type today. I didn't set any breakpoints or anything, so. Let's just try that again. Oh, you got a fully realized list there. Try it with some more. Okay. It didn't like it. Oh. No, it didn't like it. Yeah, it should be displaying ... I'll fix that, because obviously for some lazy sequences you really need that.
Does it pretty print things, or do you ask it to pretty print something else in stack frame?
Yes, with the D key, yeah, you can pretty print. So if I go back to,
Quite some horrible map thing.
well, if I go, I'll just pretty print this expression with D and C. And it should. It's going to be slow because it's coming over the.
We go 3 minutes.
3 minutes? Okay, thanks. I should have picked a smaller example. Come on. I was going to kill it and start again.
I believe it.
Okay, any other questions while we're on it?
Just is there a way to get the type of logo, its actual type?
Unfortunately, Well, you can eval a type expression, which is like the hacky way to do it. Unfortunately, the inspector isn't ported to nREPL yet. So the slime inspector, which is really useful for that sort of thing, isn't there yet. And ideally, that would go into the main nREPL rather than just nREPL Ritz.
What's the potential for using this to debug arbitrary Java applications?
You can set breakpoints in Java, so there's some facility there.
Well, there's inREPL and lining involved in starting this up, so if I just had Tomcat instance,
If you have an nREPL server running, yes. Yeah. Obviously, you can't eval code, so it's probably a little bit more limited. But if you've got an nREPL server, you must have a Clojure runtime loaded as well. So yeah, it might be interesting to explore that a little bit more. Any other questions? Sorry.
So this is essentially just an extension to the nREPL protocol, right?
Yes.
So
Well, it's not a.
fully JVM specific, or will this be useful for Clojure script as well?
It is JVM specific because it uses the JVM platform debugger toolkit to
Yeah, I
implement
mean
everything.
the implementation, I mean the protocol.
The middleware operations could be implemented. Well, I'll go out on a limb and say they could be implemented, but I don't really know.
Yeah, so I guess in essence my question was that if I were to implement like a Ritz server in Clojure script, would the Emacs side still be kind of useful?
Yes.
Okay.
Yeah, you should be able to use the same Emacs interface to Clojure script if you can get the middleware implemented.
Excellent, but I have a new project.
Okay, great. Okay, well, come see me if you have any more questions. Thank you very much.